Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.32. While solving this problem, we will be using Kirchoff's voltage law. This law states that sum of supplied and dropped voltage across circuit elements in a closed loop is always zero. According to this law, a cumulative supplied and dropped voltage in a closed loop is always zero. Now move towards the problem. Exercise problem number 2.32. Find voltage V0 in given below figure. This is the circuit diagram of given problem. We have to find voltage V0, that is across this 12 volt source and 12 ohm resistance. We will solve this problem using Kirchoff's voltage law. Before using Kirchoff's voltage law for this closed loop circuit, first we have to identify the direction of current inside this circuit. As we can see that the current Ix is labeled inside this circuit along with its direction. So we have to take the direction of current Ix clockwise. After taking the direction of current inside this circuit, now we have to assign polarity notation across resistances inside this circuit. 4 ohm resistance will have positive terminal on here because current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign according to passive sign convention theory. Similar case will be here. 12 ohm resistance will have positive sign here and negative sign here. Now write Kirchoff's voltage law equation for this closed loop circuit. We will start from Vx. Current entering terminal is positive, so Vx will be taken with positive sign. Move to the next element. Current entering terminal is negative, so voltage across this dependent voltage source will be taken with minus sign, minus 2Ix. Move to next element. Current entering terminal is positive, so voltage across this resistive element will be taken with positive sign, and the value of voltage across this resistive element will be 4 multiplied by Ix, 4Ix. Move to next element, that is voltage source. Current entering terminal is negative, so voltage of this voltage source will be taken with minus sign, minus 12 volt. Move to the last element of the circuit, that is resistance. Current entering terminal is positive, so voltage of this resistance will be taken with positive sign, and voltage of this resistance is the product of current Ix and the value of resistance, that is 12 ohm. So it will become 12 Ix. Now inside this equation two variables exist. In order to solve this equation, we have to make only one variable inside this equation, and that can be made by placing the value of Vx inside this equation. Voltage of this dependent voltage source, that is Vx, is being controlled through the voltage across this 12 ohm resistance. So value of Vx is equal to the voltage across this resistance but opposite in polarity. So we can say that Vx will be equal to minus 12 Ix. Voltage across this 12 ohm resistance is 12 Ix, and because Vx is opposite to the voltage of this resistance, that's why minus is taken along with it. Now place the value of Vx inside this equation. It will become minus 12 Ix minus 2 Ix plus 4 Ix minus 12 plus 12 Ix is equal to 0. Now inside this equation only one variable is left, that is Ix, so we can solve this equation to calculate the value of Ix. Solve this equation. This minus 12 Ix will cancel out with positive 12 Ix. The remaining equation will be minus 2 Ix plus 4 Ix minus 12 equal to 0. Now subtract 2 Ix from 4 Ix, it will become 2 Ix, and place this minus 12 on the other hand side of equal to calculate the value of Ix. Divide on both sides with 2, value of Ix will be 6 ampere. Now we have calculated the value of Ix that is flowing inside this closed loop, and the value of Ix is 6 ampere. We know the value of current Ix through this circuit. This current can be used to calculate voltage across this 12 ohm resistance, and whenever we will be having the voltage across this 12 ohm resistance, we can calculate voltage V0. We will assume there is an element and across this element voltage V0 is appearing, and this is an imaginary closed loop. So we can find out voltage across this imaginary closed loop using KVL. First, we have to mention the direction of current and polarity notation across this resistance. Direction of current is clockwise as it was mentioned in question. And according to the direction of current, polarity notation will be this: positive sign on here and negative sign on here. Now write KVL equation for this imaginary closed loop. Start from here. Current entering terminal is negative, so V0 will be taken with negative sign. Move to the next element. Current entering terminal is negative, so voltage of voltage source, that is 12 volt, will be taken with minus sign, minus 12 volt. Move to the next resistive element. Current entering terminal is positive, so voltage across this resistive element will be taken with positive sign. The value of voltage across this resistive element is 12 multiplied by Ix, current through this resistance. Now we know the value of current Ix, so replace Ix with its value, that is 6 ampere. Open these brackets. 6 will multiply with 12, it will become plus 72. Subtract 12 from 72, it will become plus 60. Now place this minus V0 on the other hand side of equal to calculate the value of V0, that will become 60 volt. So this was exercise problem number 2.32. Thank you. See you again in next video.